Hello. We're going to start chapter 7 today. Chapter 7 is all about rational functions. Um, Rational functions are basically when you have a fraction of functions somewhere. Rational means ratio. So we're going to start to explore a little bit of that today and continue next week when I get back. So the first section is 7.1, which is talking about inverse variation. If you've taken a chemistry class, you might have already talked about this. It's very similar, but we obviously do some things a little bit differently. But so how I like to introduce this is basically talking about first what a direct variation is. So let's say that you have this spring right here. This is the spring at rest. Okay, then we add a weight to it. Well, of course, you all know that when you add a weight to a spring, that spring is going to pull down. And so that's what this picture is showing you. And the more weight that you add, the longer the spring is going to stretch. Okay, we call something at rest in equilibrium. So that's where we are here. And so what we want to do is talk about, part A says, describe the relationship between the weight x and the distance d the spring stretches. So we want to know as x increases, what happens to our d? Well, if d is the distance, you can see the distance that's stretching from equilibrium also increases. So as one goes up, the other one goes up as well. Okay? We say the distance is said to vary directly. That's what direct variation is. We should have talked about that in Algebra 1. Okay? So as one goes up, the other goes up. That's called direct. All right? And we want to write an equation now to represent this situation. So let's look at, you could really choose any of these values. I'm going to choose the biggest one down here. Okay? It looks like it's measuring from the bottom right here of the spring. I know that because I'm looking at this part up here. So if we measure there, okay, we're right here. That looks to be about 10.5 centimeters. Now you could have done the same thing here. That's about 9.5. Okay, that's about 8. You could have done that as well. I just chose that one because it's closest to the ruler and easiest to see. So what you need to notice is that 0.7, okay, times some value k is going to equal the distance. That's what that means. Okay, that's what direct variation looks like. So the equation that represents this situation is 0.7k is equal to 10.5. Okay. And so when it says estimate the spring constant, that's what your k value is. The k value is the constant. It's basically how stretchy is the spring or how stiff is the spring. That's what your k value is. And so all you have to do is divide by 0.7, divide by 0.7, and 10.5 divided by 0.7 is 15. Normally there are units, but the book didn't really give us any units here. Well, that's not true. It would be 0.7, let's see, kilograms, 10.5 centimeters. So it would be centimeters per kilogram. That's actually the unit there. The thing I'd like to make note of here is that this k value is not the same k value in transformation. So if you remember, like when we had a quadratic, it looked like this, and that k value was on the outside right there. It's not the same thing. It's a completely different k. It stands for constant. And it's a constant of variation sometimes, but this time it's a spring constant. Okay. So moving on, there are two types of variation. What we just talked about was direct variation, and that's when you have y is equal to the constant times your x value. Okay. In inverse variation, we still have y equals, but this time instead of multiplying, we're going to divide. Just like an inverse of something, you thought to flip or to change, the same thing happens here. Okay. And the thing that you have to understand is that in order for us to realize if it's inverse or direct, you must solve for y. Okay? And so that's going to come in handy right here with number 2. It says tell whether x and y show direct variation, inverse variation, or neither. So we need to solve for y here. So that means we need to divide by x, divide by x.
Students staying after school for sports or school supervised activities need to be with their coaches
right. So here, since the x is on bottom and the y is on the other side, this is going to be inverse variation. Okay. On B, okay, this is neither. And the reason why it's neither is because we have this -4 on the end. This would be something that we call linear. But just because it's linear doesn't mean that it's going to be direct. Okay. This one over here, in order to solve for y, you got to multiply by 2, multiply by 2. So y equals 2x. And here we have a case where it is linear, but this time it is direct. That k value is 2. So this is an example of direct variation. Okay. All right. Same thing on this one. We got to determine if they're direct, inverse, or neither. But we're given a table of values instead. Okay, so we're just going to have to test it. So let's say you think that it's direct. If it's direct, then that means that the y value is going to be some kind of constant divided by x. And we don't know what that constant is, but we can figure it out because we're given multiple x and y values. So if the y value is 12, then that means that the x value is 2. So that means that if it were direct, the k value would be -24 because you multiply both sides by 2 there. Okay? But if it's direct at one point, it's going to be direct all the way through. So let's test it out again right here. Okay? The y value is -6. The k value is here. Okay? And then we have 4. Oh, wait, I'm lying. I'm totally lying. No, I'm not. No, I'm not. I'm not lying. Sorry. I got confused. I looked at my notes wrong. Anyway, sorry. Wait. I am lying. I wrote the wrong word. Let me back up. I'm so sorry. If it's inverse, this is what it's going to look like. Okay. Direct variation is y equals k times x. I just said the wrong word. Okay. Sorry. If it's inverse, then that means that y is going to be k over x. Okay, because that's coming from the definition of an inverse relation. My apologies. So, because of when that happens, with the first point, the k is going to be -24. And in this case, k is going to be -24 as well. You could continue along those lines there and realize that pattern is going to continue. 6 times -4 is going to be -24. 8 times -3 is going to be -24. So this is an inverse relationship. Okay, let's do another one since I clearly don't know what's happening. Let's check to see if it's inverse. If it's inverse, the y value is going to be a constant divided by x. So that means that 2 is going to be some kind of constant divided by 1, which means that the k value is 2. Okay. If that pattern continues, then 4 should be equal to k over 2, and then k is going to be 8. And the thing about the constant of variation, guys, is that the constant is constant, and it's 2 and 8 are not constant. So that means that it is not inverse. Okay? Now let's see if it's direct. If it's direct, then that means that y is going to be the k value times x. Okay? And when this occurs, that means that 2 is going to be k times the x value, which is 1. And then we're going to divide by 1. So k would be 2. And let's check to see if that's true for the next one. So let's see, 4 is equal to the k value times x, which is 2. And you would divide by 2, you would divide by 2. So k is equal to 2. Okay. Let's keep going. Let's make sure it works. 8 is equal to the k value times the x value, which is 3. If you divide by 3, divide by 3. Well, 8 divided by 3 is 2 point something, something, something. Okay, so this means that the k values are not going to match, so it's not direct either. If it were direct, that k value would be the same all the way through. So this would be an example of something that is neither direct nor inverse. Okay. Hopefully that makes a little more sense. If it doesn't, I can help you out when I get back. Okay. Okay. So now we're going to write inverse relationships. So when we're going to need to do this, this is how the question is going to be worded. It's going to say the variables x and y vary inversely, and y equals 4 when x equals 3. Okay, so if it's inverse, remember y is going to be k over x. So that means that the y value is 4. We don't know k, but we know the x is 3. And when it says write an equation that relates x and y, that means I need an x, a y, and a number. And that number is your k value. Okay, not k. I don't want to see the letter k anywhere. So we need to find the value of k and then go back and plug it in to this equation right here. And we can do that easily because we were given the x and the y value, and we can solve for k. And you can see that 12 is equal to k. So the answer that it's looking for is y equals 12 over x. That is the answer that it's looking for. Okay. Same thing on number 2. The variables x and y vary inversely, and y equals 8 when x equals 4. Write an equation that relates x and y, and then find y when x is negative 16. Okay, so this one actually takes a little further step. If y equals k over x, and you know that 8 is the y value and k is 4, then k is equal to 24. That's a lie. K is equal to 32. I can multiply. K is equal to 32. Then the equation that you have is y equals 32 over x. Okay, that would be the equation. And then find y when the x value is negative 16. So that means that you would just go in and you would do 32 divided by negative 16. So then that means that y would be negative 2. Okay. Beautiful. So for those of you that are like, Ms. Baucom, when am I ever going to use this in real life? Here's when you will. It says the time in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. Okay. And then it says, make a table showing the time it would take to build the playground when the number of volunteers is 5, 20, 25, and 30. Okay. So before we do that, we do need to look at this first sentence. It says the time and hours that it takes a group of volunteers to build a playground varies inversely with the number of volunteers. So what that means is the time that it takes varies inversely with the number of volunteers. And then there's some kind of constant k that we have to talk about there. Okay? And we know that it takes a group of 10 volunteers 8 hours to build a playground. So that means that k is equal to 80. Okay? So what that means, in case those of you are wondering, the time is in hours. The n is the number of people. Okay? So then that means when you take hours times the number of people, this is basically meaning that it takes 80 man hours. Or if one person were to complete the playground on their own, it would take 80 hours. Okay, that's what your constant means in this situation. But it wants us to make a table showing the number of volunteers and how many hours it would take. Okay, if the number were 15, 20, 25, and 30. Okay, so we know that the constant variation is k. So 80 divided by 15 is going to be 5.3 if you plug it into your calculator, okay, which is about 5 hours and 20 minutes. So if you had 15 people, it would take 5 hours and 20 minutes. If you take 80 and divide it by 20, hopefully you see that that is 4. So that means it would take 4 hours to build that playground. On here, 80 divided by 25, when you plug it into your calculator, is about 3.2. So that's like 3 hours and 12 minutes roughly. Okay? And here, if you have 30 volunteers, 80 divided by 30 is equal to 2 2/3, which is about 2 hours and 40 minutes. Okay? Which should make sense because the next question asks you, what happens to the time that it takes to build the playground as the number of volunteers increases? Well, the more help you have, the less time it takes. So the time decreases. That's the idea of an inverse relationship, guys. As one goes up, the other goes down. Okay? Hopefully this makes enough sense for you to start your homework. Whatever due date that it says for 7.1 online, that's when it's due. I'll be back on Tuesday, so you guys can ask questions then, okay? Be nice to the sub. Be nice to each other. Rachel, be positive today. And yeah, see you guys on Tuesday.